Hello everyone, welcome to day 20 of July Leetcode challenge, and today's question is shuffle an array. In this question, we are given an array of integers and we need to write the implementation of few of its methods. It's a design problem, and after a very long time we are having a design question. In this problem, we need to write the definition of three of its methods. The first one being the constructor, the second one being the shuffle method, and the third one being the reset method. So let's talk about what these methods are actually doing. The constructor initializes the object with an array that is given to us, the input array that is given to us. Shuffle returns a random shuffling of the input array. So you need to shuffle that input array in random order and return it as an answer. Reset method resets the array to the original values that were passed in the constructor. The caveat here is that all the permutations of the array should be equally likely as a result of shuffling. That means the probability of generating a particular permutation should be equally likely to happen. Without much ado, let's look at the presentation that I have created for this and let's get started. Guys, this is a very interesting question and you'll love it. Shuffle an array, Leetcode 384. And let's talk about the naive approach. The crux of the problem lies in writing this shuffle method appropriately. If you're able to return any particular permutation of the shuffled array that is equally likely to happen, then the problem is solved. Reset is pretty straightforward, constructor is pretty straightforward. So let's talk about this shuffle method. Let's hypothetically assume that the input array that is given to us has the same values as the indexes, because we only need to manipulate on the indexes. Also, since shuffling and probability and randomization is coming into picture, so we will definitely use random method somewhere. The question itself gives us a hint about it, to use random. Now let's talk about the naive approach. This is the input array that we have. The length is 7 and you pick up any particular index from this array. Let's assume you picked up 3. So 3 is gone and this gets added in your output array. Next, you want to pick up any random index out of the remaining elements. Let's assume we get 5 this time. So 5 gets added. Next we have is 1. 1 gets added. Next we have is 2, 2 gets added. Next we have is 6, let's assume we had 6, 6 gets added. Next we have is 4, 4 gets added. And last one is 0, 0 gets added. So you will see that we generated all the numbers in your output array in an absolutely random fashion. The only caveat here was to keep a track of those indexes that have been consumed in the past. And for removing those indexes that you have consumed in the past, you will require an additional complexity of order of n. So what would be the total overall complexity for this algorithm? You are keeping track of the remaining elements and you have to continue the operation till the time all the indexes have not been covered. So let's assume there are n indexes and at every removal you are doing a processing of order of n for removing one entry from the input array. So the total complexity for this approach would be order of n square, which is not that great. Can we reduce this prime complexity? Yes, we can do that. So let's talk about a better way of doing the same thing. Just one takeaway from this algorithm would be to keep track of the shuffled indexes and the unshuffled indexes. So the output array that we built was the already shuffled indexes that we have shuffled in the past, and this input array was being treated as those indexes that were unshuffled in the past. So just keep this point in mind and let's try to optimize it. We'll be using Fisher-Yates algorithm to optimize this solution, and I am attaching the link of the wiki page of Fisher-Yates algorithm. It's quite overwhelming, but don't worry. If you are interested in learning about it further, do give it a shot. But I'll explain everything that is stated on the wiki page. So what we are trying to do, we are again trying to build the array in two parts. One, those indexes that we have already shuffled, and the other one being the unshuffled indexes. So let's walk through a test case and you'll get good hold of the concept. Right now, what is the state of this array? All of them are unshuffled in nature. So you'll pick up any random index from this unshuffled array up till the last length. Starting from 0 up till 6, pick up any random index. So let's assume we picked up 2. And what you're going to do, you'll swap 2 with 6. So 2 with 6 gets swapped, and the updated array is something like this: 0, 1, 6, 3, 4, 5, 2. And what you're going to keep track of, you will keep track of the shuffled indexes. This has been shuffled, so here we are done. We'll not use this index again in future. What is the size of the unshuffled array? The size of the unshuffled array is 6. So you will pick up any index using the random method starting from 0 up till 5, and let's hypothetically assume that you got 1 this time. So you'll pick up, you chose 1, and you are going to swap the 5th index with 1. This gets swapped, and what is the updated array? 0, 5, 6, 3, 4, 1, and here we have 2. So where the boundary wall is going to come? The boundary wall is going to come at this particular index. Again, you will do the same thing. This is the unshuffled array, this is the shuffled array, and you'll pick up any random index from 0 up till 4, and let's hypothetically assume that you got 6 again. So you'll swap 6 with 4. What is the updated array? The updated array is something like this: 0, 5, 4, 3, 6, 2, 1, 2. And where does the boundary come into picture? The boundary comes here. Again, you will do the same thing. You'll pick up the random index from this particular length, 4, starting from 0 up till 3, and let's hypothetically assume that you got 5 this time. So you'll swap 5 with 3. The updated array is something like this: 0, 3, 4, 5, 6, 1, 2. And where does the boundary come into picture? Here. So this is the shuffled array, this is the unshuffled array. Again, let's do the same thing. Out of 0 up till 2 index, you'll pick up any particular index, and you will shuffle that with the last index that we have. So this one will be shuffled with, let's assume we got 0, and this is gone, this is gone. You'll shuffle these two. The updated array is something like this: 4, 3, 0, 5, 6, 1, 2. You define the boundary here, and again do the same thing. You swap these two because there are only 2 elements, and the updated array is something like this: 6, 4, 0, 5, 6, 1, 2. The boundary comes here. There's only one last element. It doesn't matter, you want to generate the random number up till this length, 0. You'll obviously get 0 here. You'll swap 0 by 0, and the boundary wall gets shifted here. The process is complete, and the answer is something like this. The time complexity of this approach is order of n, because you are reducing one index that is there at the end of your input array with each iteration, and you'll require n iterations to completely process the input data. I hope you understood this logic. Let's quickly move on to the coding section. The first thing that I have done here is to define my input array, an integer array of nums, and another variable random that will help us generate the random numbers. In the constructor, I initialize this dot nums to the one that was being passed in the question, and I initialize random to new random. In the reset method, it's pretty straightforward. I simply return the nums method. I'm not doing anything else. Let's talk about the core part, the shuffle method that we have. I create a copy of my nums array so that I don't manipulate over the nums array, because I need to return it in the reset method. And I taken an iterator I that starts from the end of the length of the input array, I equals to nums.length minus 1. I generate a random index, and that will be starting from 0 up till nums.length, because I here is nums.length minus 1, and you need to have one higher index, therefore I plus 1 is being used here. It generates random number from 0 up till nums.length minus 1. And once I have that index, I need to perform the swap operation. I create the value at it in a temporary variable, and I'm just swapping the values at the ith index versus the one at the randomly generated index. And I keep on doing the same thing, and I reduce the value of I with every operation. I simply return back the copied or the randomly generated array. I should have used randomly generated array, random array rather than copy. Let me just update it. That sounds better. Yeah, let's try this up. Accepted. The time complexity of this approach is order of n. I hope you got the context and enjoyed today's session. If you did, please don't forget to like, share, and subscribe to the channel. Thanks for viewing it. Have a great day ahead, and stay tuned for more updates from Coding Decoded. I'll come again tomorrow with another fresh question.